Good morning. So I want to start off by talking about exam 2 and kind of giving you some tips on how to prepare and overview of the exam. Okay. After that, I'll be happy to take questions related to whatever you have related to the preparation. So exam 2, as you know, has covers modules 3 and 4. The topics are regression or curve fitting, interpolation, numerical differentiation, and numerical integration. Please refer to the section numbers indicated in the syllabus. Okay. In the exam, there will be 4 problems, one on each. One problem on each topic. So the nature of the problems will be such that there will be a question or a problem statement. Okay. And you can solve that problem either entirely manually or using Excel. Okay, you are allowed to do both, and you can record the solution on paper. So you have to record the solution on paper. We will collect only the paper. On paper, only the work on paper will be graded. We will not collect your Excel sheet or MATLAB code or anything. Will be graded. Excel, or if you choose to use MATLAB or any other package, will not be collected. You don't have to include screenshots, you don't have to send us anything. Overall, the exam itself is going to be 80 minutes. Open book or notes, meaning you can bring any material you want, you can bring any tool that you want, and all you have to do is answer the 4 problems, one on each topic, and give me a paper submission that we will grade. Okay. And if you choose to do all of this just using calculator and pencil, that is fine. You don't have to use Excel if you feel there is no need to. All right. Ultimately, the questions will be asking something in the end. It will be asking something like present the answer or solution to say 4 decimal points or something. That answer is what we'll be looking for. Okay, and associated error estimates wherever applicable. Associated error estimates wherever applicable. Now, how would you prepare for this? So for each topic, there, first step, do the problems on homework 3 and homework 4. Homework 4 is, by the way, due on November 2nd. In addition to that, for each topic, for each of the 4 topics, I will post 4 suggested problems for each topic. That is 4 times 4, 16 problems that I will post. You should absolutely be able to solve those 16 problems. What I am trying to do is trying to give you question templates similar to which I will ask questions in the exam. So if you should be able to solve those 16 problems that I suggest. And okay, there was a question. So 4 times 4 times 4, 16 problems, which I hope to post sometime by end of tomorrow. Okay. And I know in my syllabus I have not indicated explicit office hours, but I always put meeting by appointment is always welcome. So far, I have had very few students actually show up and talk to me or email me or ask me in person that they want to discuss, which is not ideal. So at least for the next few days, that is on Monday, I'll be available 2 to 3 p.m. via Zoom, and on Tuesday, I'll be available 2 to 3 p.m. in person, and Wednesday, I have generally good availability. Just email if you want to talk. The exam, as you know, is on Thursday. I will post these 16 problems. I expect you to try. I expect you to get some get ahead. But if you get stuck, I want you to come talk to me. If I just post the solution, and this being an open book exam, what people will do is show up with that solution expecting a similar problem with changed numbers. I don't want that situation to happen. Okay, I want you to try get stuck so that I can help you get unstuck. Okay, so that's why please come see me, talk to me. If there is so much demand, I will be happy to open up more times where I can meet you. Okay, in fact, Tuesday, we also have from 1 to 2 p.m. our recitation session, which I know some of you cannot attend because you have other classes, but I'll be sure to record it and post the recording. Is there any other help that I can provide? Please tell me. What I understood by talking to a few students is that most people don't seem to read my emails. I'm sorry that I don't have time to give this message in person to each person individually. Given that we all have hectic schedules, I thought email is very efficient to communicate, but it depends on actually you reading the email. That is not happening, then I think at least some parts of this information, especially relating to this being an open book exam, 4 topics, 4 problems. I think I put all of these through emails. I hope it came across, but if not, here it is on camera. People watching from home, please don't forget this. Any questions before we move on? So at 12:30, the TA will be here to hand out homework 1 graded work. He is uploading your scores as we talk. He is also working on homework 2, which we hope to complete by tomorrow. And I plan to grade exam 1 myself, and I hope to have you the graded exams by next Tuesday. Okay, so next Tuesday when we meet, we will be handing out both homework 2 and exam 1. Okay. Is it already 12:30? I said 12:30. 12:30. Yeah. Yeah. So we'll hand out that is homework 1 that we have ready. So we'll hand out homework 2 and exam 1 on Tuesday. Okay. I look around, I see some nods of approval. There is any frustration, I would like to hear now. We still have about 1/3 of the course remaining, which I can do something about instead of in the evaluations. I know once at the evaluation, you get a chance to speak anonymously. I know you can speak, but please speak now. I'll definitely take it as possible. Yeah.
For homework 3 and for the exam, they're kind of the same, but what I was more so getting confused on is when I would do like, as we've done in class, like the Excel sheet, do all the equations in the Excel sheet, but then I also basically have to do the same thing on paper. So is that what we have?
That's a great question. So when I say I will take only the work on paper, I need at least what process you went through. So if, for example, you're doing quadratic interpolation, you would write out the starting equation. You might set up the problem in Excel and get the numbers from there, and you can just say these numbers came from Excel and put it on your sheet. So ultimately, this course is about doing the calculations methodically and getting an answer. So we will check the flow of your logic through the steps you write. So a bad way to take this exam would be to just take the problem, get the solution on Excel and just write the answer alone. That will be terrible because we don't know what went on between the start and the end. You have to provide adequate detail. That is why we are not collecting your Excel or MATLAB work, because students will just be sending us screenshots which we have to interpret for them. You put on paper what you would ideally do if you didn't have Excel. Is that making sense to you? You use Excel, that's fine, totally fine. It's like using a calculator. Now you have to write it up properly and submit it. Yes.
So if we were setting up like a system of equations with summations, we could just write down the formula we're using, and then the next line just have the number subbed in.
Yep, that's exactly what we want to see.
Table needed to be drawn or anything.
You don't have to draw the table. You just say, here is my, based on the given X and Y data, you would put it in Excel and get sigma X, sigma XY, sigma X squared Y, all those. And you can just write sigma X or N equal to 10. Sigma X equal to 45.2, sigma Y equal to 355.6, something, sigma X squared Y, X cube Y. You can just take these numbers from Excel and put them here and we will check these. So actually, since you asked, let me kind of do a simulated example. So suppose you're doing regression and you are given data that looks like X, Y, and number. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say you have 10 entries. So how would you set this up to do? Suppose we ask you do a linear regression. So you would say Y equal to mx plus b, and to solve for m and b, we set up sigma y equal to m sigma x plus bn, sigma xy equal to m sigma x squared plus b sigma x, and then you need these coefficients, right? Using Excel, sigma x equal to sigma y equal to sigma xy equal to sigma x squared equal to, you just get these numbers from Excel. And then next step would be putting the actual numbers here and writing two equations into unknowns. So like say for example 305 equal to m times 45 plus b times 10, and then 4255 equal to m times 415 plus b times 45. And then you have two equations in two unknowns, which you can solve using any method that you know, including punching it into your calculator and writing m equal to b equal to. This is the answer which we will check. So usually when we grade, we try to look at the solution process as a whole. Is there a flow? Then the next step is, have they written the critical equations or the starting points correctly? So the starting point would be either this or this. And then the steps are to do the calculations and the final answer is this. So this is how you would solve. This is the level of detail we need. It's not a course or it's not middle school where we are testing your multiplication skills. We are trying to test you whether you can set up this and then get two equations in two unknowns and then finally get those two numbers. That's. Yes,
So we don't need to show you anything about the method that we use to like solve these equations.
you don't need to. I've given you access to all the information in this universe and your calculator. So you don't have to show me how you got from here to here. You can use your calculator. Yeah,
Is there any way we could get homework with that, you guys just like graded, so you could at least. Anything like that?
you want your own homework again?
Yeah.
Be fine with the solution.
Or
Yeah, that-
I can post solutions. I can post solutions to homework 3 and 4 by early hours on Monday. Yeah. Yeah, I'll try to post solutions. So what I owe you is these 16 problems by Friday night and the solutions by Monday early morning. Yeah,
But homework 4 is due on the next Thursday and the conclusion on Monday.
yeah, I don't. I mean, I know I'm giving out the solution and basically letting everyone score 5%. I'm happy with that rather than people showing up in the exam and not being able to answer questions. So because the exam is worth more, it's like 20%. It's I don't have to be you'll make enough mistakes, don't worry. There will be a distribution, a Gaussian distribution with most of the class in the middle. And then some high scores and some low scores. In my 10 years of teaching, I've seen this happen semester after semester, regardless of how much or how little help we provide. Sorry? It's not basically.
correct, but still.
Sorry, I'm an engineer, not a poet. All right, any more questions?
So going back to those linear equations, so you don't want us, because we also practice like just graphing it and getting the numbers off of your graph like so, but you don't want us to do that.
How will you do graphing?
Well, like for, I guess not necessarily linearization, like for a polynomial. Like if we got a data point, we set a line to it.
Yeah, sure. If you are thinking about using Excel to do like a linear regression and getting the slope and intercept from there, you can also do that for a quadratic regression. But you still have to explain how that works.
Okay.
You can't just pull numbers from somewhere, even if they are correct, and if you just present this, you will get nothing. Because these steps, you have to explain how you got the numbers. That's what this course is about. Yeah,
So I know for stuff like this, we have to like go basically show what steps we're using to get to where we're going. Like, can we just write it out, like with words instead of numbers?
no, you have to put numbers. Again, engineering, not poetry.
I mean, engineers explain stuff with words.
But they also base it on numbers. The words by themselves don't constitute anything. It's the numbers that are explained using the words. So I've seen in homework 1 submission that some people did one problem or one method out of 6 methods and write. I didn't have time to do the remaining 5, or I got similar answers from the next 4 methods. Those all don't count as explanations. You have to do the work and precisely tell how these numbers were arrived at. That is what this course is about. So don't give any explanations in your paper. We want numbers and the steps. So if you find the student, if I go through these steps, there is no more explaining to do. Here is my method. This is least squares regression. If you remember the name, or if you want to write the name, you can write it. This is least square regression, and then this is using Excel. I'm telling my source, and then this is 2 equations in 2 unknowns, and then this is my solution which I get from my calculator. That's all I need to say. I don't need to write any prose there.
So for the writing, like on these tests, pretty much all you care about is just in our brain, what steps you're following, you don't care about anything else.
Yeah, we have to, it has to make sense. It's hard to give you clear cut rules about this. But if I read it, it has to make sense. That's all, and I'm going to read it. That's why I've taken upon the exam grading upon myself to actually see what you are thinking. So it has to make sense to me, and in my grading, I'll try to put remarks, what is missing or what is not clear to me. Other questions? Yeah.
So some classes have been giving out extra credit if we dress up for Halloween. Is that offered extended a year?
So I do give you a, what's the time? So I do give you that option to take a final in the end. So which is worth 60%, which you can use to substitute if your exam scores don't measure up to what your expectations are.
What if I wear the costume?
That'd be like 61%, maybe.
November.
Exactly, how it's a punishment.
And okay, I've been thinking about this not in response to what you said. In general, the attendance has been steady. There are a few people who come and don't come. It varies. It's not the same people who are absent all the time. Mostly, you all as a group have been steady with attendance. So I'm thinking I'll just give the 4% attendance score to everyone. So that I'm just trying to I didn't want to say it now, but you asked and I have to say it. But you've been steady, so let's reward that. But what I'm somewhat concerned about is I went through a few exam one the exams. It wasn't looking good. It wasn't trending good. So that's why I took some time off to talk about this, offer some contact with you and some help in terms of posting the solutions and some practice problems. If you, again, I emphasize, I know there's a lot of stuff to study in this course, but if you can't do these 16 problems, the odds of you able to do the exam problems, 4 of those, will be low. I want you to put a lot of effort into solving these 16 problems, come up with questions. Most of the time when I get anyone contact me, it's a blanket thing, like I don't understand anything. I want you to try something, get stuck somewhere and show me what work you went through so that I can see what's going on. Like if you just tell me, can you explain everything? I can't go over the entire course once again. That's hard. You don't have time for that. So watch out for this email from me tomorrow. Okay. All right.
But if we wear a costume on Halloween, do we get a point of extra credit? Is it a yes or no?
Well, see, I don't want to kill all the Halloween spirit. But I don't want to say yes either.
Like if we come in, like we might get extra credit. My man. Oh, yeah.
Let's talk about that. I have to think. Yeah.
Can you say maybe just so I can see him in a Halloween costume?
Okay. If I say maybe, I also have to say what perk I'm going to offer. I haven't thought of it. By end of the class, maybe I'll get some idea.
Just say that you will and then stop.
Oh, if I do that, once you are on this side, you will know the students will just destroy you in their evaluation. You promise something and don't deliver, you're done. I'm done. All right. Okay, serious time. Let's go back to our in numerical integration. We still have work to do there. We haven't finished that topic. So please open your textbook and look through problem 21.1.
The example one or the practice problem?
The end of chapter.
I have two. That's not gonna-
I had and right and that avoid. Hey, I know we are connecting and everything, but I liked you when we were cold and disconnected. Can you please keep it down? We have a class to go to. Problem 21.1. Okay, let me pull up my screen. Okay, so again, this is just putting numbers into what we discussed last time about doing the integration numerically, treating the entire interval as a single segment. We are going to try that with 2 segments, 4 segments, and then use Excel to say maybe divide this not into just 4, but maybe 100 segments, and see how the accuracy can be very easily achieved if you divide this interval into fine enough intervals. So step 1, look at the integral and get the analytic value so that you can have a benchmark to go against. What is the analytic value? 0 to pi by 2, 6 plus 3 cos x dx, that is 3 pi plus 3 times sin x from pi by 2 to 0, that is 3. So this is 3 times pi plus 1. Can you tell me the numerical value, please? 12.4 decimal points.
12.4247.
Thank you. So we'll call this I exact. The value of the integral exactly is 12.4247. And now we want to use trapezoidal rule. And we are going to treat this as a single segment. Single application of the trapezoidal rule, and you just need to remember 2 formulas, one for the single segment and one for multiple segments, or at least know where the formula is so that you can look it up. So equation 21.3 I equals b minus a over 2 multiplied by f of a plus f of b. In our case, a is 0, b is pi over 2, and the function f of x being 6 plus 3 cos x. I know this is a very dumb example, like very simple example, but it's just for you to get that practice. Okay, so you think it's too easy for you, there are many more difficult problems that you can try later. So go ahead, compute this. You want to get, I'll call this I1, meaning one segment, I1 equal to pi by 2 minus 0 divided by 2. What is f of 0? F of 0. 6 plus 3, 9, right? F of 0 is 9. And f of pi by 2 is 6. cos pi by 2 is 0, so that is 6. So you have pi by 4 multiplied by 15. Please compute and tell me what that number is.
Four decimals.
To 4 decimals, always.
Got 11.7810.
11.7810. Thank you. So for single segment, the error would be 1 minus I1 divided by I exact expressed as a percentage. So your target is 12.4247. You got 11.7810. So you're clearly falling short by what percent?
5.18%.
1 point?
No, 5.18%.
5.18%. Sorry, come again.
Somebody might want to double check it.
Yeah, if anyone else gets a different value, let me.
I also got 5.181.
Yeah, let's say 2 decimal point. We're just saying it's about 5%. Okay. So if you just apply the trapezoidal rule just once, meaning I didn't. So if you take your interval, which is 0 to pi by 2, you start at 9 and then you go up to 6. So this is the area that you are trying to calculate through this integral. And we are getting, or if I ask you to visualize or draw the shape of the trapezium here, how will it look like? Its sides will be, this will be a side from 0 to pi by 2, and then this vertical side, and then from 0 to 9 another edge, and then you have to draw a straight line connecting these 2 points. So this is the trapezium that you just evaluated, and the area under the curve is what it is. So if you have to indicate what the error is, this portion is the error, is the difference in areas between the exact value and the calculation using one segment. Yes.
But the I3 formula you gave us, you know the formula?
Yeah.
That last time. What is sum of I equals 1 to n minus 1?
We are going to do that. So we. Any other question related to this calculation? Is it making sense? Okay, simple enough. Just treat the entire interval as one segment. Okay. Now we are going to do the next step, which we'll do it as 2 segments. So I'm going to take 0 to pi by 2. And I'm going to divide that into 2 segments. So pi by 4 is my midpoint. And I have my curve running from 9 to 6. So it has to go through something like this. And I'm going to turn this into 2 segments. So whatever this value is, this is my segment 1. And then, segment 1 and then segment 2. Pardon my drawing skills with the mouse. Not that my hand drawing skills are any better. So now you want to compute the value of the 2 areas by applying the trapezium rule twice, once between 0 to 4 and then once between pi by 4 to pi by 2. So you can do it using the formula given in the book, or you can also do it sort of intuitively, which I like to do. So remember that this is your formula. It is true for any interval where A is the starting point and B is the ending point. Okay. So I'm going to write I2 is the value of I using two segments. I'll write this is equal to I from 0 to pi by 4 plus I from pi by 4 to pi by 2. I'll split that into two applications of the same formula. For the first segment, A is 0, B is pi by 4, starting point, ending. For the second segment, what is the starting point, ending point? Pi by 4 is the starting point, pi by 2 is the end point. So you can simply take this formula and literally apply it two times, once for this and once for this, while paying attention to the A and B values. Okay, so why don't you try that and then look up. I will write out the formula. So I have I2 equal to pi by 4 minus 0 divided by 2 f of 0 plus f of pi by 4. And then I have plus pi by 2 minus pi by 4 divided by 2 f of pi by 4 plus f of pi by 2. You can very well compute all these quantities, get a number here, get a number here, get their sum, and write the answer. That is simple enough. You can also do pi by 2. You can just literally add these and see what remains. Like for example, you will have pi by 4. Yeah. Pi by 4 divided by 2 multiplied by f of 0 plus 2 times f of pi by 4 plus f of pi by 2. You can also evaluate this and write the answer. And please do the calculation one way or the other and tell me the number.
I got 12.2689.
12.2689. So we'll say error equal to 1 minus I2 divided by I exact expressed as a percentage. It has gotten better. It's 2689 versus 4247. So it's getting closer.
1.25%.
1.25%. Thank you. So when you had a single segment, the error was 5.18%. When you have two segments, the error has reduced to 1.25%. So a typical exam question would go like, here's an integral which may or may not be directly integrable. So you will be asked to evaluate that integral with a certain number of segments, say 4 or 1 or 5 or whatever. And then this error is absolute error. There is absolute error is when you compare truth versus an estimate. The truth in this case being the exact value. Suppose you have an integral which is not easily integrable to get an analytic answer, or if you have a table of data, say for example, you have x and f of x as a table presented to you, and you're asked to calculate what is the integral from a to b of f of x dx, which you have to do numerically. We are going to see how to do that now. We are going to do an example where the function is not given to you in analytic form like this, but given to you in tabular form like this. This is tabular form. This is analytical form. So you might be presented the function in either way, analytic or tabular. Okay. Yes,
So is the error a relative error or absolute?
this is absolute.
Okay,
Because we got this error by comparing with the exact value.
so last class you said this was a relative error.
There is another formula for estimating the approximation error as well, which I was just about to say. So this was just like a sidebar that I mentioned that the problem can be presented in another way also. So we'll do an example on that. Okay. Now coming back to this problem. Coming back to this problem, if you look at the trapezoidal rule, equation 21.3 is for the single application. And then if you want to do repeated application, you have equation 21.10, sorry, 21.10. So let me write that here. Equation 21.10 gives you I equal to B minus A being the width multiplied by f of x naught. Whatever I call as A is there, x naught. So we'll just keep it there, f of x naught plus 2 times I equal to 1 to n minus 1 f of xi plus f of xn divided by 2n. So this is for multiple segments where n is the number of segments. Okay. So if you put n equals 2, you will recover the problem we did by repeatedly applying. Yes.
Never mind, I see.
So now I want to see if I can solve the same problem we did with n equals 1, we did with n equals 2. I want to see if I can set up an Excel sheet to do this with say 10 segments or 100 segments or whatever number of segments. Let's try to do this on Excel. Okay. So if you are doing, you have your Excel ready, please pull it up. So here's the problem. Okay. So we are going to write the start of the interval a equals 0, b equals pi divided by 2. Okay. And we want to do say n equals 10 segments. N equals 10 segments. So I'm going to write x naught. X naught is nothing but your a. Okay. And then x1, x2, and so on. It goes up to xn, which is equal to b. So I need to have x3. This column D I'm writing for your reference. Okay. I don't need to write it otherwise. Okay. So I have I starting from 0, 1, 2, and you can just drag it all the way until B. Okay. So to keep it kind of clear in your head, if you have say x naught and xn, let's say n equals 3. So you have x1, x2. How many segments do you have? 3 segments, right? So you're starting with 0 and you're going up to 3. So that is 4 points and 3 segments. We are starting at 0, going up to 11 points. That is 11 minus 1, 10 segments. Okay, so this is basically 10 segments. So now you have the counter. Step 1 is to write xi. Okay, what is xi? It is nothing but a, which you freeze, plus I times okay, before I do that, I need to compute what is the step length, which is b minus a divided by n. So in this case, it will be b minus a divided by n. So do it up to here, and then we'll populate this xi.
That is 2.
The 2 is kind of like a common factor, but if you think about the step width, that is just if you have length n and you chop it into n pieces, it's L by n. So we have the starting point, ending point, number of steps required, and then the step length, which is in this case 0.115708. So xi is the starting point A plus I times your step length. So I'll write it here. Xi equal to x naught plus I times delta x. If you put I equal to 0, you just get x0 equal to x0. So that makes sense. X1 will be x naught plus 1 times delta x. X2 will be x naught plus 2 times delta x, and so on. So you can see where this is going. This Excel file, I keep posting it to the class website. So hopefully you will see it more leisurely later as well. Okay, so I'm going to press enter, and then what I did here also is to put the dollar sign before B2 and B6 so that B2 and B6 values are frozen, and as I drag it, only the row value gets updated. Okay, so by this time, if you have been using Excel, I think you know what I mean. So I have my xi values. Okay, look at your formula. Your formula involves computing the function's value at x naught, at xi, and then at the last point xn. And you have the x values. Now you have to punch in your analytic function so that you can compute what is f of xi. F of xi. So what is f of xi? It would be 6 plus cosine of whatever xi is. Okay. let's take a time out here, one or 2 minutes for you to catch up and get up to here to see if you got the same numbers as I have here. Yes, right there, 6 plus 3 cos 6. So if you are doing this for your homework and if you have this Excel sheet with you, each problem will change in the region of integration, the range, number of segments that you want to use, the step length will change accordingly. And but the core is, if you update the function, you can generalize this spreadsheet for all the problems that are in your homework or in your textbook. That is the skill I am trying to pass on to you, which is you should be able to set it up in a general way to solve many problems and not just a problem. Okay. Those who are trying, are you able to get up to here? Yes, yes.
Can you just explain one more time how it's 11 points, how it's 10 segments, but
So if you take a very simple example and you say I have x naught, x1, x2, how many points are here? 3. How many segments are here? Any other questions? Okay, so we have f of xi. Now your formula is looking like there is a common multiplier and then there is a summation. But if you look at this summation, this intermediate values of xi are multiplied by 2, whereas the terminal or the boundary values are multiplied by 1. So I'm going to define to keep the programming easy and clutter free. I'm going to define a weighting factor. What is the weight of f of x x naught? Weightage. Weighting factor is 1. Weighting factor of all other points is 2. Weighting factor of the last point is 1 again. So I'm going to call it W of I. Okay. For the first point, the weighting factor is 1. Second point, it's 2. Until the last point, it remains at 2. And then I have 1. So now I'm going to write Wi multiplied by f of xi, which is H2 multiplied by G2 and if I drag it down, this column here, column I, is basically all the terms within this square bracket. Column I is all the terms within the square bracket, with the first and last point having a weightage of 1 and all intermediate points having weightage of 2. I'm teaching you this trick because the next method we'll learn is called Simpson's rule, where the only thing that will look on the appearance of the formula is the weighting factors. You can use the same spreadsheet. You just have to update the weighting factors corresponding to Simpson's rule instead of trapezoidal rule. Okay. So if you sum it up, what do you get? Is that the answer? That is, if you do the summation of this, you get something. Are we done? Is that the value of the integral? Is this 169 the value of this integral? What else is remaining for us to do? Yeah,
B minus A over B minus on the outside.
we have to multiply it by the width of the interval, which is b minus a over 2, and also divide it by a factor of 2. Sorry, b minus a by n, which is the width of the interval, and then divide by 2 to make it consistent with the formula for trapezoidal. So now let's do that. So this is not the answer. This is just the summation. So I using 10 segments would be half times the step length times the summation. What are we missing here?
Can you say the last part again? 1/2 times the step length times the summation.
1/2 times the step length times the summation. B minus A over N being the step length,
Okay.
half is the factor and this summation. But the answer we are getting is. Are we making some mistake here? There is no such thing as too many segments, or maybe there.
If we work for 10 segments, you currently have. Well.
Oh, okay. So hold on. Oh yeah, I have 12 segments. So I have, oh, this is my last point. So xn or x10 equal to b. Thank you. So I don't need this line. If I do that and change the weightage, because now this is this weighting factor. So I'll write a remark here. Wi, the weights are corresponding to the trapezoidal rule formula. So that's a good catch that I had left, not 10, but 11 segments. So from 0 to 10, that's 11 points minus 1, 10 segments. If I do that now, my answer is coming out to be 12.4186 with the exact being 12.42. So let's compute the error. So I exact is 12.4247. So the absolute error is equal to 1 minus expressed as a percentage. It's not 0%. It's we have to give it more decimal points. 0.049%. So did we get all the steps right? Did I make any other mistake? Trapezoidal rule. Before I come to you, any specific questions on what we did? Yes, what is the question?
Can I see what you changed for your summation?
Can I?
Because I didn't think about that.
So summation is really simple. I just summed up these 11 values. That's it. Because I've already included my weightage. I mean, you could do it one other way too, which is you can take the first and last value separately, the middle values, sum them up separately and then multiply it by 2. But by using the weightage, like I said, when we go from method to method, it's easy to jump. Okay. So 1 minute here for you to catch up. And then what I want to do is, we want to compute the error estimate using equation. I'll tell you from what equation in the book. So this error here at the bottom, 0.049%, that is absolute error. Whenever you use the word absolute, what we are implying is somehow the truth is known and you compare it against that gold standard. When you do error estimate, when you are estimating something, when do you estimate? When you typically don't know it for sure. That's when you have to estimate. That comes from a different formula, which I'm going to show you, which we saw last time, but I'll bring it up here now. Can we move on? Those who are trying. Okay. So if you see here, formula 21.13. Formula 21.11. Formula equation 21.10 gives you the formula, and then equation 21.11 gives you the corresponding error estimate. Gives you the corresponding error estimate. So I want you to punch in this formula into your spreadsheet and then compute the total error estimate. It's easy enough. It's just taking the step length, cubing it, dividing by 12, adding a negative sign, and the second derivative of your function. Yeah.
Okay, can you put a formula that you use in your hydrogen segment?
Yeah. This one
No, the iPad segment
is this one.
below, summation.
Oh, this one. Half times the summation multiplied by the step length. Negative what?
Negative number for total errors. Is that possible?
It's possible, yeah. It's definitely possible because the derivative, the second derivative can take any sign. Okay, so all right, so I'm going to now compute f double prime of xi. What is f double prime of xi? Given that our function is 6 plus cos 3x. What is second derivative of this? 3 sin x and then, I'm sorry, minus 3 sin x and then minus 3 cos x. So it's simply minus 3 cos x, right? So that is equal to minus 3 times cosine of xi. And then drag it down. So the second derivative of the function evaluated at each grid point, that is your second derivative estimates. And then we want to do a summation. Similarly, let me paste the formula here so that you don't have to keep going back. Here's the formula for the error. So it involves getting the second derivative at each of the grid points, summing them up, and then multiplying by this factor. Now, strictly speaking, this zeta I has to be a number between, say, x0 and x1 or x1 and x2 and so on. For simplicity, I'm just taking them to be the starting point itself so that we don't have to keep choosing it every time. Okay. So what is the formula for error? You have to add a minus sign divided by 12 minus 1 over 12. The step length cubed, step length is here. I need to cube it and then multiplied by this summation. So that is my this 0.0064 is my error estimate. What do you understand by that word error estimate? And when I say that estimate is equal to 0.00664. Yeah,
Does it mean the reduction in our error from adding another one?
No. What is the purpose of all this? What are we trying to do from the beginning? We want to, what is the goal of doing this trapezoidal rule? You know the answer and you don't want to say? Sorry? Find the area under the curve or evaluate the integral. The reason we learned these techniques is that not all integrals can be analytically solved or analytically calculated. So we are trying to use numerical method and we came up with the estimate 12.4186. And suppose you didn't know what the true answer is. You could not know, because if you knew the true answer, why bother doing all this? You have an estimate or you have a value for the integral 12.4186. And what you're saying is the error associated with this calculation is at least this number. When you say error estimate, it is usually a lower bound for saying the error with this number is at least this. It could be more because there is a third derivative, there is a fourth derivative. As you compute more terms, this error estimate will slightly keep increasing, but not too much. It will still remain bounded. So when you put out a number like 12.4186, the implication is whatever the truth is, which we don't know, it is likely to be at least this much or more different than the estimate, than our calculation. Is that statement making sense? Because somebody could ask you what is the difference between absolute error and error estimate, and you should be able to say absolute error is what you get by comparing with the correct answer, and when you don't know the correct answer, you make an estimate. That is what we call the error estimate. That is what this ET is, error estimate. Okay. So if for your exam, you could get a problem like this one, maybe not the same function, but some function, and given a limits for the integral, you might have to divide this into 4 segments or 5 segments, some reasonable small number of segments, and get an answer as well as the error estimate. In the problem sheet, I just use these terms like approximately calculate the value of this integral. And along with your calculation, please estimate the error associated with your calculation. So in that case, you would present the value you get with 5 segments, let's say, and the corresponding estimate. It may or may not be a function for which you will be able to exactly get the integral. It might be some function which you can't analytically integrate. Okay, so be prepared for these scenarios. That's why I'm saying in the 4 problems that I'll suggest, to try to work out those, but I'm not implying only those 4 problems are enough for your preparation. You should try to do more. Okay. So now this problem involves us specifying the function and the limits. Instead of a function where you can divide the interval into as many segments as you want, suppose you are given a table of data, how would you compute the integral in that case? That's our next flavor. And once we learn that flavor, the remaining topic in this unit is to see what is called as Simpson's rule, which, if I were to say, it's another derivation or another level of approximation for the integral. So you will get a formula that looks like this, but with slightly different weightages. Okay, so Simpson's rule we'll see at the end. We'll start at 12:35. I want to just see if I can at least mention the next example. So formulas that you need to remember are pretty much what I listed here. Equation 21.3 single application, equation 21.10 multiple application with n segments, and equation 21.11 is the error estimate. Okay. It would really help you if you kind of knew where to look during the exam, because it usually is stressful. You know, you don't want to keep searching then. Okay, so note it down. In fact, even since this is an open book, don't be complacent. If you would, whatever you would do for an exam where I allow just one sheet of notes, I would still suggest you do that, because that will save you time in the exam. Exam, like being successful in exams is about strategy more than your depth of knowledge, or it's as much important as depth of knowledge. Okay. All right. So I want to just quickly show you an example, or show you the problem we want to try, and we'll pick it up on Tuesday. All right, so problem 21.11. Evaluate the integral of the following tabular data with the trapezoidal rule and Simpson's rule. So you are given the x value and the function at interval of 2. So each segment is of length 2, so that is clear to you. Now you have to apply the trapezoidal rule. You don't have to do anything new. The spreadsheet we already have will actually work. I'll show you how. What is the step length? 2. How many segments do we have here? 1, 2, 3, 4, 5, 6. 6 segments. Okay. So if I go back to my spreadsheet, so if I copy this spreadsheet, oops. Okay, move or copy. This is problem 21.11. I'm going to replace this with this. Oh, 21 point, sorry, I've copied the wrong thing. Okay, so I'm trying to use trapezoidal rule here. Okay, what is my A? What is my starting point? -2, end point is 10. Okay, so that won't change. -2, 10. And what is my step length, which is already sort of decided for me? I can't change it now. 2, that is from the table. Step length is 2. It's already given, x is given at resolution of 2. Okay, so I'm going to put step length equal to 2. And what is the number of segments? 6. I'm sorry, number of segments is 6. So now if I look at this table, I didn't do anything else. The xi value just got updated automatically because I had already set it up. I need up to x equal to 6 because 10 is the last value, and the other values 7, 8, 9, 10, I don't need them because they are not part of my calculation anymore, so I'll delete it. Okay, what is f of x? It's still not 6 plus 3 cos x because that is the previous problem. F of x is coming from my table, so I have, somebody has to read this to me. 35. Oops. This is 35. What's the next x value? 5. -10. 2. 5. Sorry? 3 and 20. 3, 20. Okay. According to my trapezoidal rule, my weightage factors must be 1 for the first and last point, and for the intermediate points, the weightage factor is 2. So I have my weight multiplied by f of xi, and if I sum that, I get 65, and I have 6 segments, what is my answer? Half times B6, which is 2, multiplied by 65. Okay. So let's talk about this second derivative separately. Until now, did you follow what I did? I took my old spreadsheet. The previous problem had a function specified, meaning f of x was given to me as a function, so I can compute it at each row. Now, this data, that is f and g, are just given to me directly. I updated my endpoint, my starting point, my step length. X was populated automatically, and f of x, where did I get that from? I manually entered or copy pasted, it was given to us, right? So now I computed the summation, and then I have to multiply it by this factor, b minus a divided by n times 2, where step length happens to be 2, so they just cancel out, half and 2 cancel out. So my I6 is also 65. Okay. There is no exact answer here, we don't know, so we can't do this. Here's an interesting problem where you are asked to compute or estimate the error. How will I get f double dash of xi? I just have a table of data. How will I get that?
Differentiated numerically.
Who said that? Nice. So this is a nice problem, sort of combines the numerical integration concepts and also numerical differentiation concepts. So you will have to pick out a formula for f double dash of xi. From where will you pick that in your textbook? If the answer is in figure 23 within 5 seconds, it means you are going to be looking through your pages on the exam day. So when you go to chapter 23, there is figure 23.1.2.3, which has all the differentiation formulas. So you should pick one of those and use it to compute it here. Okay. So either in this exam, or if you take the optional final, which is comprehensive, we might club these kind of concepts together, so that instead of 4 problems, it will be 3, but the third problem will have 2 concepts tested in one place. Okay.
You have those solutions to the 16 practical problems.
No. That runs the risk of people bringing those solutions to the exam and expecting something dead similar and then getting disappointed. Okay. So we'll do this calculation in the next lecture to finish this, but you can also try on your own. Okay. So now the TA will distribute the homeworks which you can pick.